This is GMAETS 41. You are welcome to our Introduction to Calculus class. In this video, we are going to focus on the topic limit. So we're studying the concept of limit of a function. And what is the limit of a function? It's simply the value to which that function approaches when the variable in that function approaches or tends to a given value. Now that value it tends to can either be a constant, can be infinity, or it can be an expression that contains a variable as well too. Now I mentioned infinity, please. It's important for you to know that infinity is not a number. Is that okay? It's not a real number. It's a quantity whose property is far greater than any real number you might think about. Now we have properties of 0 and infinity that you should know. We have 14 of them, and then we have others that leads to indeterminate terms, meaningless terms. So you can't even get your result. They don't have answers, alright? And in these properties from 1 to 14, it's on the condition that a is not equal to 0. Then a can be greater than 0, which is a positive number, or a can be less than 0, which is a negative number. Expectedly, please, you have to memorize these properties as much as you can. Now, you want to look at property number 1 to 14. If you really look at it, you notice that it's actually dealing with the constant a, which could be less than 0 or greater than 0, and then infinity. Now, areas that we have 0 in the operation, it's when you're dealing with 0 and the constant, alright? Not 0 and infinity. Take note of that. You can see that here where 0 is introduced. Take note here, a divided by infinity is 0. 0 is not in the operation here, you know that, right? Okay, now in the indeterminate term, if you look at it much more, you see that you're dealing with infinities and zeros specifically. Then look at this, 1 raised to power infinity, 0 raised to power 0, infinity raised to power 0, they are also indeterminate, they don't have values, okay? So before now we used to know 1 raised to anything, the power of anything is 1. And 0, any number raised to power 0 is 1 as well. So please, that does not include these terms here, right? So you want to take note of them. Now in the next video, we're going to pick questions to see how we handle problems like this. When you encounter indeterminate or meaningless terms, then you need to introduce certain concepts of mathematics, sometimes do certain differentiation or do certain division so as to be able to work around it and actually get your result. Now we have our first question on the board here on the limits. We have to find the limit of the function x squared plus 2x plus 1 as x tends towards 2. So you see we're given the function is a function of the variable x. So we have f of x is equal to x squared plus 2x plus 1 as x approaches tends to 2. It's important for you to know, yes, x is not actually 2 here. It tends, it approaches, that don't get confused. I'm just saying this because there are certain type of questions we're going to encounter subsequently where this fact that x is not exactly 2 will become very important. Anyway, until we get there. For this problem, we're going to substitute x equal to 2, right? In this function. And if we do that, this is going to give us, we'll come to this function and you will see x, we put 2. So that's going to be 2 squared, and then plus here, this is 2 times the value of x is 2, then plus 1. If you simplify this, 2 squared will give you what? 4. Then 2 times 2 will give you 4 plus 1. 4 plus 4 is 8 plus 1 is 9. Therefore, f of x, which is equal to x squared plus 2x plus 1 as x approaches 2, will give us the value 9. So, okay, so when x is approaching 2 here, f of x in this function will be approaching what? 9. And that's the solution to this problem. And now, the second question. For a limit problem, we have to evaluate the limit of 6x over 2x plus 1 as x tends or approaches minus 1. So how do we solve this problem? Alright, remember, so we're going to play around this, nothing is there, is that okay? So we are evaluating limit of 6x all over 2x plus 1 as the value of x, which is the variable, approaches minus 1. So what do we do here? We're going to substitute minus 1 for x, is that okay? So this is going to give us 6 bracket minus 1, then divided by 2 times minus 1 plus 1. Okay, so let us solve this out and see. 6 times minus 1 will give us minus 6. 2 times minus 1 will give us minus 2. Minus 2 plus this one will give us what? Minus 1. So this is minus 1. And then if you divide through, you see that this negative will cancel out until we get 6. We can now conclude the limit of 6x over 2x plus 1 as the value of x tends to minus 1 is going to give us what? 6. And that's the result of that limit problem. Now we have a question number 3 on the board. It's a past question of 2016-2017. We are to evaluate 4 minus x squared over x minus 2 as x approaches 3. So it's a limit problem. 4 minus x squared over x minus 2 as x tends towards 3. So that's going to be equal to 4 minus, in place of this x, we're going to put the value of x, which is 3, and then square it. Please be careful at this point. Take note that this square is not affecting this minus. Is that okay? It's not. It's only affecting the value of x. And so we're going to have over, in place of this x, I'll put 3 minus 2. So let us simplify and see. This will give us 4 minus, you see that, right? Evaluate 3 squared. 3 squared will give us what? 9. All over 3 minus 2, which is 1. So you see that this will give us minus 5 as our result. Is that not so? 4 minus 9 is minus 5. Therefore, limit of 4 minus x squared over x minus 2 as x approaches 3 is equal to what? Minus 5, which means that the function itself will be approaching minus 5 as the variable x approaches 3. Now, there is a question I want us to look at, okay? That question is going to help us to see that there are some cases when a problem is given to you. In most cases, they belong to polynomial, and it's a fraction, numerator and denominator, polynomial. It might be necessary that you factorize before substituting the value that the variable is tending to. Or you may apply what we call the hopitalRule by differentiating denominator and numerator before substituting the value of the variable given to you. Okay? If you don't do that, you might just land yourself in trouble. Let's look at the question 4. Evaluate limit, okay, x squared minus 1 all over x minus 1, okay, as x tends to 1. Solution. So look at this problem. We have to evaluate limit of x squared minus 1 over x minus 1 as x tends to 1. Numerator and denominator are both what? Polynomial function. And then if you look at it, you notice that the numerator can be factorized. The numerator is difference of 2 squares. That is x squared minus 1 squared. If you do what we've been doing in previous questions where you substitute directly, you will land yourself in trouble because this will give you an indeterminate term, a meaningless term. And so how do you handle this problem? There are 2 ways to do that. Either you differentiate numerator and denominator before substituting, or you can factorize, okay? Factorize the part that is factorizable. And I'm going to use the factorization process anyway. So looking at the top, this is difference of 2 squares. Remember, if you have a squared minus b squared is equal to a minus b, and then a plus b. So we'll apply that here. This will be equal to x minus 1, then x plus 1, all over x minus 1. Good. You now notice that this x minus 1 will cancel this x minus 1, so that the question given to us is the same as this. It's the same as what you're going to see on the board. You see that? That is x plus 1. So it is this x plus 1 we'll now use to solve our problem. We'll substitute 1 here because x tends to 1 plus this 1. If you do that, you get what? 2. Therefore, limit of x squared minus this all over x minus 1 as x tends to 1 is equal to what? 2. So that is one way to solve this problem. As an alternative, let me write or. We can decide to say that limit of x squared minus 1 over x minus 1 as x tends to 1 is equal to limit, you differentiate denominator and numerator. So let's differentiate the numerator. If you do that, you're going to get 2x over 1 if you differentiate the denominator. Now from here, as x tends to 1, if you differentiate x squared, you get 2x. Derivative of constant minus 1 is 0. Differentiate this x, you get 1. Derivative of this minus 1 is 0. Okay, so from here you can substitute your 1 for x. If you do that, what will you get? You have a 2 bracket 1, and that will also give us what? 2. If you don't want to substitute here, for this particular problem, you can still differentiate this term again. If you differentiate this term, you get 2 finally, which becomes your answer. Alright, so either way, it's your choice. But I prefer to use this factorizing method, okay? Now we're going to see more of this type of question as we solve the next problem. Now we have the fifth question on the board here. We are to evaluate limit of 2x cubed plus 3x squared minus 2x minus 3 all over x squared minus 1 as x tends to 1. So how do we solve this problem? Okay, we have limit of 2x cubed plus 3x squared minus 2x minus 3 all over x squared minus 1 as x tends to what? 1. It's important for you to look at the board very well and then see if you can factorize it. At least quickly you notice that the denominator can be factorized, is difference of 2 squared. We've encountered that in question 4 before. Then the numerator is a polynomial of degree 3, so you want to check if it can factorize. Is that okay? I want to check if it can factorize, and I'm going to use the Omak's assumed factors to factorize this. Alright, you can visit the GMAETS 41's YouTube channel. Please, you can visit that so that you would learn how I will quickly factorize the numerator. Okay, so this is going to be equal to limit x tends to 1 of the numerator. So to factorize, you're going to do the second degree coefficient divided by the third degree coefficient, and then that's going to give us 3 over 2. So you have that in store, you can write it somewhere. So let's say 3 over 2, dividing this coefficient by this. Then we shall seek for the factors of 3. 3 factors of 3. Why 3 factors? You are dealing with polynomial of degree 3, is that not so? So 3 factors of 3, which if you add, you're going to get 3 over 2. The over 2 can be obtained from there by dividing one of those factors by these 2. So what are the 3 factors of 3 that we're going to use here? And I will be thinking that there are only 2 factors of 3. You are not wrong, but you know in polynomial factorization now, you use a plus and minus concept. Is that not so? So 1 and 3 are factors of 3 already, no argument, but 1 is a perfect square. So you're going to have 1 and minus 1 there, making it 2 1s. Is that not so? 1 plus, the other one minus. Then added to the 3, giving us the 3 factors. So the 3 factors we're going to use here is going to be, okay, minus 1, 1, and 3. Okay, so we are going to add these factors to see how we can get 3 over 2. And so from these factors of minus 3, we are going to select the Omak's assumed factors. Now, in the Omak's assumed factors, one of these 3 factors must be divided by 2. So that once you add them, you can get 3 over 2. And when you watch this method, the Omak's assumed factors method from our YouTube channel, you will notice what I said regarding which one usually bear the division by that constant. Alright, in this case, it's either the first or the last term. And of course, whichever you introduce the divided by 2 should be such that if you add them, you will get 3 over 2. So from what I'm seeing here, it's going to be this. So I will come here and then say that this is over 2. If you add minus 1 plus 1 and 3 over 2, add them together, you're going to get 3 over 2. Okay, if you add them. Of course, it's going to be, in the addition, you do LCM, you have 2 times minus 1, which will give us minus 2, plus 2 times 1, which will give you 2. Minus 2 plus 2 goes off. So you're now left with 3 over 2. And of course, we've gotten the factors. The factors that will solve this problem for us is minus 1, 1, and plus 3. And so we're going to write these as x minus 1, and then x plus 1, and lastly 2x plus 3. So that's the factors of these. Please, we encourage you to visit the YouTube channel to learn this process, okay? It will help you to solve the question in 1 or 2 steps if you are to factorize the given polynomial. Of course, the polynomial must be factorized in the table. Alright, so here, this and this we cancel, this and this we cancel. And then you notice that what you're actually solving now is limit as x tends to 1 of 2x plus 3. Okay, so we shall substitute 1 there, and if you do that, you have 2 bracket 1 plus 3. Therefore, limits of 2x cubed plus 3x squared minus 2x minus 3 all over x squared minus 1 as x tends to 1 will give you, if you work out this, you're going to get 5. Is that not so? So the result is 5. So by factorization procedure, this is what you do and you get this result. You can also use the L'Hospital rule or the L'Hopital rule. Please don't judge me, okay? There is a L'Hopital or L'Hospital, both of them supposedly are correct. The man himself spelled the name as L'Hospital. But of course, due to alteration in French or spelling another thing, the S has been removed in modern time. Okay, now, so it can either be L'Hopital or L'Hospital. Now, what do you do there? Just differentiate the numerator and denominator once. After differentiating, substitute your 1 for whatever you get. So you can do that, is that okay, as a self-test work. Once you differentiate the numerator and the denominator once, substitute 1 in whatever you get, simplify, and you still get this result, 5.